Welcome to JavaScript Interview Prep. Today we're doing the deepest dive into var, let, and const that you'll find anywhere. 3 keywords, but their behavior changes completely depending on where you use them. We're going scope by scope, global scope, function scope, every type of block scope, hoisting, the temporal dead zone, redeclaration rules, and edge cases that trip up even senior developers. No fluff. Let's go. Let's start with global scope. When you use var at the top level, outside any function, it does something most people don't realize. It attaches the variable directly to the window object. So var greeting equals hello means window greeting is also hello. They're the same binding. And you can redeclare var as many times as you want. No error. The old value just gets silently overwritten. But here's the dangerous part. Because var attaches to window, you can accidentally overwrite built-in globals. Look at this. Var JSON equals a string. You've just destroyed the built-in JSON object. JSON.parse is now undefined. Your entire app breaks. This is why var at global scope is genuinely dangerous. Now let and const at global scope. Completely different behavior. They do not attach to the window object. If you declare let framework equals React, then window.framework is undefined. So where do they live? In a separate scope that the spec calls the script scope. You can see it in Chrome DevTools. Open the Sources panel, pause on a breakpoint, and you'll see it listed under Scope as Script, separate from Global. This means let and const can never accidentally overwrite browser built-ins, and they don't allow redeclaration. Try to write let framework twice in the same scope, and you get a syntax error. Not at runtime, at parse time. The engine catches it before your code even runs. And const goes further. You can't even reassign the value. Attempting to reassign throws a type error. Function scope. This is where var was designed to work. Every var inside a function is scoped to that entire function, no matter where you write it. Look at this process order function. We declare I and price inside the for loop. But after the loop ends, both I and price are still accessible. I is 3 because the loop finished. Price is 30, the last item. var doesn't care about the curly braces of the for loop. It only cares about the function boundary. The good news is that var is contained by the function. Outside process order, total, I, and price all throw reference error. So functions do create a hard boundary for var. It just ignores every other type of block inside that function. Now let and const inside a function. They respect both the function boundary and every block inside it. Here, tax and total are declared directly inside the function body, so they're accessible throughout the function. But I and price are declared inside the for block. The moment that closing brace of the for loop is reached, I and price are gone. Dead, trying to access them after the loop gives reference error. This is the key difference. var only sees functions as boundaries. Let and const see every pair of curly braces as a boundary. This makes your variables much more predictable because they only exist exactly where you need them. Let's get into block scope, starting with if-else blocks and var. In getDiscount, we declare var discount and var message inside the if and else branches. After the entire if-else, both variables are accessible. var ignores the block. It's hoisted to the function level. This actually works in this case because both branches assign values. But look at risky check. We only set result inside the if block. If flag is false, that assignment never runs. But result is still accessible after the if. It's just undefined. The var declaration was hoisted, but the assignment wasn't. This is a subtle source of bugs. Your code doesn't crash. It silently gives you undefined, and you might not catch it until production. With let and const, if you need a variable after the if-else, you must declare it before the block. In getDiscount, we declare letDiscount and letMessage first, then assign inside each branch. Now they're accessible after the if-else because they're scoped to the function body, not the if block. Alternatively, look at getLabel. We use const label inside each branch. These are 2 completely different variables. Each one dies at the end of its own block. We must return from inside the block to use the value. After the if-else, both labels are gone. This forces you to be explicit about what you intend, and the engine catches mistakes for you at parse time. For loops are where var causes the most confusion. With var I in a for loop, there is exactly one variable I for the entire loop. Every iteration mutates the same variable. When we use setTimeout, all three callbacks capture a reference to that one I. By the time the callbacks execute, the loop is finished and I is 3, so all three print 3. And I doesn't die after the loop, it's still accessible. It leaked out into the function scope. It gets worse with nested loops. Var j in the inner loop also leaks out. After both loops finish, j is still accessible and equals 2. In a complex function with multiple loops, this can cause collisions where one loop accidentally reads a variable left over from a different loop. Now let in a for loop. The output is 0, 1, 2, what you'd expect. But the reason is deeper than most people think. It's not just block scoping. The ECMAScript spec has a special rule specifically for let in for loops, described in section 14.7.4.2 called create per iteration environment. Here's what happens. Before each iteration, the engine creates a brand new lexical environment and copies the current value of I into a fresh variable. So iteration 0 gets its own I with value 0. Iteration 1 gets a completely separate I with value 1. Each setTimeout callback captures a different variable. After the loop, I doesn't exist at all. Reference error. It's completely contained. This per iteration binding is unique to let in for loops. It doesn't happen with var, and it's a special case in the spec. Now here's one that catches people off guard. Const and irregular for loop throws TypeError. Why? Because const I equals 0 works for the first iteration, but I++ tries to reassign I, and const doesn't allow that. But const works perfectly in for of and for in loops. Why the difference? In for of and for in, each iteration creates a completely new const binding. The first iteration gets const color equals red. The second gets a new const color equals green. There's no reassignment. It's a fresh variable each time. This is actually the most correct way to iterate over arrays and objects. Const signals that you won't mutate the loop variable inside the body, which makes your intent crystal clear. Let's cover the blocks people forget about. Switch statements are a common trap. The entire switch body is one block, so if you declare let MSG in the success case and let MSG in the error case, you get a syntax error because both declarations are in the same block scope. The fix is to wrap each case in curly braces. Now each case has its own block, and each const MSG is a separate variable. Try-catch blocks also create scope. Variables declared inside the try block die when the try ends. The ERR parameter in catch is scoped to the catch block. And anything you declare inside catch, like const fallback, also dies at the end of catch. Every pair of curly braces that creates a statement block creates a scope for let and const. Even bare curly braces with no if or for, just braces on their own, create a scope. Now let's get into hoisting. And I mean what the engine actually does, not the simplified version. JavaScript executes in 2 phases. Phase 1 is the creation phase. The engine scans your entire scope, not the whole file, just the current scope, and finds every declaration. For var, it allocates memory and immediately initializes the variable to undefined. For let and const, it allocates memory but does not initialize. The variable exists in memory but is in an uninitialized state. This is the temporal dead zone. Phase 2 is the execution phase, where code runs line by line. This is when assignments actually happen, so when people say var is hoisted, they mean it's both allocated and initialized during creation. When they say let is hoisted, they mean it's allocated but not initialized. That distinction is everything. Let's see it in code. We log A, B, and C before declaring them. Variable A, declared with var, prints undefined, not an error, undefined. The engine allocated and initialized A to undefined during the creation phase. Variables B and C, declared with let and const, throw reference error with a specific message. Cannot access B before initialization. Notice it doesn't say B is not defined. It says before initialization. The engine knows B exists, it allocated it, but it refuses to let you read an uninitialized variable. The comments below show what the engine conceptually does. Var A gets undefined immediately. Let b and const c are created but left in an uninitialized state. The assignments at lines 8, 9, and 10 happen during execution, and that's when b and c finally leave the TDZ. Now the temporal dead zone edge cases that break people's mental models. First one, we have let x equals outer, then inside a block we try to log x before declaring a new let x. You'd expect it to read the outer x, but it doesn't. It throws reference error. Why? Because the inner let x shadows the outer x for the entire block, including the lines before the declaration. The TDZ starts at the opening brace, not at the let statement. Second, you might think typeof is safe because typeof undeclared returns the string undefined without throwing. But typeof on a variable in the TDZ still throws reference error. The TDZ overrides typeof's normal safety behavior. Third, and this is nasty, default parameters are evaluated left to right. So if parameter A has a default value of b, but b is the second parameter, b is in the TDZ when A tries to read it. This is a real bug that shows up in production code. Last piece of the puzzle, redeclaration rules. var allows redeclaration in the same scope. var x equals 1, then var x equals 2. No error. It silently overwrites. This is why typos with var create silent bugs. You think you're making a new variable, but you're clobbering an existing one. Let and const do not allow redeclaration in the same scope. You get a syntax error caught at parse time before any code runs. But in different scopes, the same name is fine. Let name in an outer scope and let name in an inner block are two separate variables. The inner one shadows the outer one inside the block, and the outer one is restored after. One more important rule. You cannot mix var and let for the same name in the same scope. Var A and let A in the same scope is a syntax error. The engine prevents this ambiguity entirely. While and do-while loops follow the exact same rules. Var inside a while loop leaks out. After this while loop, item is still 20, the last assigned value. It's scoped to the enclosing function, not the loop. With let and const inside a while loop, the variables are trapped in the loop body. After the loop, value and temp both throw reference error. They're gone. Same thing with do-while. The const x inside the do block is scoped to that block. After the do-while, x is dead. One thing to note, unlike for loops, while loops don't get the per iteration binding behavior with let. The let I we used as the counter had to be declared outside the loop because the while condition needs to reference it. That's var, let, and const at the deepest level. Global scope, function scope, if blocks, for loops, for of, for in, while loops, switch statements, try catch, every single scope type. You now understand hoisting, the temporal dead zone, per iteration bindings, and redeclaration rules. This is JavaScript interview prep. If this helped, subscribe and hit the bell. We go deep on every topic. See you in the next one.